Hello guys, welcome to all of you. Let us see a question on region of operation of BJT. In this question, it is said that in the circuit shown below, BJT has VBE set voltage 0.8 volt, VCE set voltage 0.2 volt, and beta is equal to 100. Find the region of operation of BJT and calculate VCE and IC. So this is the circuit given to us, and the biasing of 5 volt at base and 10 volt at collector is given. We have to find out the region of operation of this BJT and the VCE voltage and the current IC. So let us see how can we solve it. First of all, we will assume that this BJT is in saturation region, and we will assume at input this is loop 1, this is loop 2. If we apply KVL in this loop 1, then we will find out this equation, that is 5 minus 50 IB minus VB minus 2 into IE. The IE value can be written as IB plus IC. We should remember that we have assumed that this BJT is in saturation region. So here the value of IC equal to beta IB cannot be written, since this formula will be applicable only when the BJT is in active region. So IC is equal to beta IB can be used only when the transistor is in active region. Since we have assumed that this transistor is in saturation region, so we will not use the value IC is equal to beta IB. By solving and putting the values given here, that is VB set is equal to 0.8 volt and VC set is equal to 0.2 volt, we will find out this equation number 1. Now we will apply KVL in this output loop. Here if we apply KVL, then we can see that by moving from collector to emitter, we can see that 10 minus 3IC minus VC minus 2 into IE, and IE can be written as IB plus IC. So we have write this equation here. We will put VC is equal to 0.2 volt, and this equation number 2 can be achieved. If we will solve equation number 1 and equation number 2, then IB value can be written as 5.46 into 10 to the power minus 3 milliampere, or we can say 5.46 microampere, and IC value will be equal to 1.95 milliampere. This IC value has been calculated by assuming that this transistor is in saturation region, so it will be a I sat value, means the collector current in saturation region. Now we can calculate minimum base current required to operate this transistor in saturation region. Then this will be equal to IC sat upon beta, and its value will be equal to 19.5 microampere. As we can see by comparing IB and IB minimum, then IB value is less than IB minimum value. So we can say clearly that this BJT is in active region. But we have assumed that this BJT in saturation region. Our assumption was wrong, and this IB value and IC value cannot be considered for this circuit. So now we will assume that this transistor is in active region, and accordingly we will solve this problem. As we have seen that this BJT is working in active region now, so we can apply IC is equal to beta IB and IE is equal to IB plus IC. If we put IC is equal to beta IB, then it will become beta plus 1 IB. In active region, the base to emitter voltage can be written as 0.7 volt for silicon and 0.2 volt for germanium in NPN transistor, and if it is a PNP transistor, then these values will be according to silicon and germanium, that will be VEB voltage. So this is the circuit given to us. Now if we apply KVL at input node, then this equation can be written as 5 minus 50 IB minus VBE minus 2 into IE. We will put IE is equal to beta plus 1 IB. So we have put beta plus 1 IB here, and we will solve it, and by putting the values VB is equal to 0.7 volt and beta is equal to 100 given in the question, then IB value can be calculated at 0.017 milliampere, and IC will be equal to beta IB. We put the value of IB here, and we will calculate IC is equal to 1.7 milliampere. If we apply KVL in loop 2, then this output loop, then it will be equal to 10 minus 3IC minus VC minus 2 into IE equal to 0. By putting the value of IC, that is beta plus 1 IB, VC can be calculated as 1.46 volt. Here the value of IB can be written from here. So we have calculated the value of IC, that is 1.7 milliampere, and VC, that is equal to 1.46 volt. So this is the answer of our question. In this way, first of all, we will assume that our transistor is in saturation region. If our calculation interpreted that our assumption was right, then that will be answer for the calculated parameters. If our assumption is wrong according to interpretation, then we will consider that BJT is working in the interpreted region, and accordingly we will solve the problem and we will calculate the required parameter. See you guys in next video.